Please title these notes Antiderivative 6 Notes, Particular Solutions, and write today's date. At the end of this lesson, you should be able to find particular solutions for antiderivatives, meaning that you can find a number for C after doing our normal taking the antiderivative procedure. So if you remember way back from Antiderivatives 1, that's this one right here, we talked a little bit about how when we take the antiderivative of something like 2x, it could equal x squared plus or minus really just about anything. We kind of had this family of curves that if we moved it up and down, the derivative would still be the same regardless of which of these curves we were on. And so we notated that by saying that the antiderivative of 2x was x squared plus c, the c standing for some unknown number. Well, sometimes we don't just want to have any of these family of curves. We want to have a specific one. We want to know exactly what that C number is. And that's what we're going to be doing in this lecture. So the instructions and how you know that this is what you're doing is that you're going to see something that looks like this. Find the function whose derivative and initial condition are given below. And all this initial condition means is it means that we know that when x equals some value, f of x equals some other value. Basically, if we have our family of curves, we're told that there's some particular point that we know the curve goes through, and we're finding the curve that goes through that particular point. So what that looks like is something like this. Let's say our first problem, we know that the derivative of f is 2x. And we know that f of 1 equals 3. So when x equals 1, y equals 3. So what we're going to do is we're going to start off doing our usual, I should say, antiderivative. We're going to say that f of x is the antiderivative of f prime of x with respect to x. And we know that f prime is 2x, so we know that f of x equals the antiderivative of 2x with respect to x. This is x to the first power, so we add 1 to our exponent and then divide by the new exponent. And then we have that plus c, just like we always have. We can simplify this, that cancels out. We know that f of x equals x squared plus c. So this is where we were in this situation in terms of antiderivatives. 1, we know that it could be one of these curves, but we're not sure which one. So now we're going to go back and we're going to say, well, if we know that when x equals 1, f of x or y equals 3, we can use that information to solve over here for what c is. So what we're going to do is we're going to take this 1 and we're going to put it in for x. I'm just going to write it again over here. I'm going to put that right in for x. And we're going to take this 3 and we're going to put it in for f of x, that whole thing there. And then we're going to solve for c. So f of x equals 3, x equals 1. So 3 equals 1 plus c, subtract 1 from both sides, 2 equals c. This is not our final answer. Our final answer is to write the whole thing out again. This whole f of x equals x squared plus 2. This piece came over here, and then this 2 went in for c. So it's the same thing that we've done before, there's just this little bit of substitution here at the end. We can also do this same thing if we have u substitution. So let's do another problem. Let's say we know that the derivative of f of x is cosine of x times sine squared of x. And we know that when x equals pi, f of x equals 6. First thing we're going to do with this one is we're going to make sure that we rewrite this sine squared x. So just like we did up in the first problem, we know that f of x is going to be the antiderivative of f prime. So the antiderivative of the cosine of x, sine squared x is same as sine of x, quantity squared. And now we look here, we remember our u substitution, and we say, well, this sine x is inside another function, it's inside that squared. So I'm going to go ahead and let u equal the sine of x. Take the derivative. Derivative of sine is cosine. And then get dx by itself. And substitute back in. So f of x is the antiderivative of the cosine of x. Let's see, sine of x was u. D of x is du over the cosine of x. Cancels out nicely. So we're going to have the antiderivative of u squared du. So far, same as we've done in the past. So when we do that, we add 1 to the exponent, u cubed, divided by 3 plus c. Here's where we would have stopped, but now we're going to come back. We're going to come and use this initial condition to figure out what is c. I'm going to go ahead and do that way over here. So we've got f of x equals, oops, that's not going to work. If I've got f of x, I can't have u in there. I forgot this last step, which would be to put my u back in the equation. So this should be sine of x cubed over 3 plus c. And then f of x is sine of x cubed over 3 plus c. We know that f of pi equals 6, so we're going to put 6 in for f of x and pi in for x. So we're going to have sine of pi cubed over 3 plus c. Now we need to find the sine of pi, so I'm just going to draw my axes. This point is -1, 0. Sine is the y. So sine of pi equals 0. 6 equals 0 cubed over 3 plus c. 0 cubed over 3 is just 0, so 6 equals 0 plus c. 6 equals c. Now I'm going to take that 6 equals c, I'm going to put it back in over here. And there we are. We have our particular solution. Now let's check for understanding. Go ahead and try this problem on your own and restart the video when you're ready. Your problem is, we know that the derivative of g is 4x times 2x squared minus 1 to the third power, and we know that g of 1 equals 8. So we want to find the particular solution for that. Pause the video now. Okay, so the first thing we've got is setting this up. G is going to be the antiderivative of this. We'll let u be 2x minus 1 because that's inside this other function here. When we take the derivative, we have du over 4x equals dx. Substitute that in here, substitute u in there. The 4x's cancel out. Now we're going to take the antiderivative of u to the third, du, add 1 to the exponent, divide by the new exponent, and then remember to plug back in. So we have 2x squared minus 1 to the 4th power divided by 4 plus c. Now the new part is to use this equation plus the information that we had on the initial condition to get that final equation with the number in for c. So we know that we put 1 in for x right here, and we put 8 in for the whole g of x. So 8 equals 2 times 1 squared minus 1 to the 4th, all over 4 plus c. Once we simplify that, 2 minus 1 is 1, to the 4th power is 1, divided by 4. 8 equals 1/4 plus c. Subtract 1/4 from both sides. 8 minus 1/4 is c. 7.75 equals c. Plug that in, there we go. If you left this as a fraction, totally fine. That concludes Antiderivative 6 notes.